안녕하세요 여러분, 해리입니다. So in this video, we are going to resume from where we stopped in trigonometry last time. So for this video, we are going to start with trigonometric equations. So like what we did for log and exponential, after we learned those two, we try to solve equations involving log and exponential, right? And now what we're going to do is that we're going to solve equations with trigonometric ratio. So for example, let's say we have an equation like this, and we want to find the value of x satisfying this equation, and we will also have a restriction, because remember that sine repeats all the time, right? So if we don't have any restriction, then there are infinitely many solutions. So either we have to write the general form of the solution, or we have to find the specific solution within this domain. And general solution in IB is not, general solution is not in the syllabus of IB, so don't worry about that. Alright, so we have to solve this equation, and like what we did for log or exponential equations, let's try to make this equation to our familiar form. So what I mean by familiar form is that we don't know how to find the value for sine. Let's say we don't know yet. So we quickly make a substitution. So let sine x be a. Then we have a very nice quadratic equation. So we move -1 to the left hand side. Then factorizing this, we will have this, right? So a equals to half and a equals to 1. That means sine x equals to half and sine x equals to 1. So okay, this is where the thing gets important. So using this boundary, some may just directly compute the value. Well, you can do that if you're confident with that, but what I recommend others to do is that I strongly recommend you to sketch the graph within this domain and then find the values for these outputs. So this is how the graph would look like from 1 to -1. So now we want to find the values of sine, values of angle, where sine x equals to half. So half must be somewhere here, right? Y equals to half. And we see that there exist two intersections, right? So that means there are two solutions with this. And sine x equals to 1, so that means we also draw y equals to 1. And we see one intersection, right? So total, we should have 3 intersections. So for this one, we use special angle. So sine x equals to half, that means that angle must be 30 degrees. And using the symmetry, so that difference, so this difference is 30 degrees, right? Then this difference should also be 30 degrees. So 180 minus 30, that should be 150. And sine x equals to 1, we have 90. So total, we have 3 values, and that's it for this question. Note that this graph is just for you to find the values, and examiners will not grade your graph, so you don't have to sketch it very nicely. A rough graphing is also fine, okay? Don't spend much time on this, because the examiners, again, will not grade your graphing. That means you will not be given with any point with this diagram, okay? So don't spend much time on this. Alright, then let's try another example. And this time we use one of the trigonometric identity that we learned from last lecture. Alright, so we want to solve this equation within this domain. And you can see that unlike the previous question where the subject is all synchronized so that we could directly substitute it, right? But for this question, we have both sine and cosine, right? That means we can't use substitution directly. So what we can try is that we can either synchronize the subject, not either, we can, yeah, so we should try to synchronize the subject. And how do we do that? We recall sine squared plus cosine squared equals to 1. So we can see that this sine squared we can write in terms of cosine, right? But this cosine x, it's very difficult to write it in terms of sine. So we think that this is better to change in terms of cosine. So what we can do is that we see that sine squared equals to 1 minus cosine squared. So replace sine squared as by 1 minus cosine squared. Then now you have an equation of cosine only. So what you can do is that you can now use substitution. Well, if you can directly factorize this, it's also fine. Well, actually it's not hard to factorize it directly. Yeah, just cosine x. But those who are not that familiar with trigonometric ratios, yeah, you can always use substitution to make the equation more familiar. Because at least for you, quadratic is more familiar than trigonometric, right? So this is what we have, and then just normal factorization. So we have two candidates, a equals to half or a equals to -1, right? And a is cosine, so that means cosine x equals to half and cosine x equals to -1. And again, it's better to just sketch it quickly and then find the value. So from 180 to -180, that means looks like this. So cosine half, where is it? I mean, yeah, so cosine x equals to half, that means y equals to half, right? So this is where 1 is, and this is where -1 is. And cosine x equals to -1, that means, oops, okay, so it should be like this. So how many intersections do you see? I can see that there are 4 intersections, right? So this one, and this one, and this one. So cosine x equals to half, what is it? It's 60 degrees, right? That means using the symmetry, we can also find this angle, which is -60 degrees. So x equals to plus minus 60 degrees for this. And then when cosine x equals to -1, that means 180 and -180, so plus minus 180. And that's it. So simple, right? So now I'm going to move on to a bit more, just a bit more complicated question. So now we are going to try some transformation. Transformed trigonometric function. So you can see that this question, the unit is in radian, right? That means your answer must be in radian too. The reason why we could use degree here is because the question is also in degree. That's why we can write the answer in degree. But as you can see, the question is in radian, so you have to write your answer in radian, okay? Alright, so let's try this. So let's rewrite this a bit so that we can cancel 2, so we have this. Alright, so one thing, well, if you want to sketch this and then do it, I will not stop it, but there's an easier way. So again, we can substitute this because, so we all know how to sketch tan 2x minus pi over 3, although it takes time. So since we have learned transformation already, yeah, it shouldn't be that difficult to sketch this. But as you can see, transformation has a lot of steps, so it will take time regardless of the difficulty. So what we can do instead is that we know how to sketch tangent x directly, right? Then why don't we just substitute this input as just one variable, so that we just need to sketch this. But note that in order to sketch it, so what I mean by sketch is that we sketch to find the value, like what we did here. And remember that we need the boundary, right? So we need the domain to sketch, right? But this domain is in x, right? And now we changed to u. That means we can find the domain for u as well. So then how do we do that? So we know that x lies between 0 and 2 pi, including 0 and 2 pi. So that means if we multiply 2 on every value, we will have this, right? And we subtract pi over 3. So something like this, okay? So that means we can find this value from this region because that equals to u. So now it's u, and we have negative pi over 2, so that means negative pi over 3 must be somewhere here, right? And so negative pi over 2, pi, 2 pi, 3 pi, right, 4 pi. And then 4 pi minus pi over 3, that means should be somewhere here, right? And so it has been restricted from these two. And then just sketch a normal tangent curve. Well, I didn't expect to have these many answers, but anyway, so now we want to find the value where tangent equals to root 3. So root 3 must be somewhere here, right? So y equals to root 3. Then how many intersections do you see? So first we see this one, second, third, fourth, and do we see intersection here? No, we don't, right? So we have these 4 intersections. So tangent equals to root 3, then what should be the angle? It should be 60 degrees, but since we have radian, why don't we write that into radian? So pi over 3. Then what about this? Again, use the symmetry. So from 0, it has the difference is pi over 3. Then from pi, the difference must be pi over 3 too, right? That means we add pi over 3 to pi, so 4 pi over 3. And we add pi over 3 on 2 pi, that's 7 pi over 3. And we also add pi over 3 on 3 pi, so that's 10 pi over 3. So that means the value of u satisfying this equation with this domain is we have 4 values like this. Is that a no? Because we want to find x, right? So what we need to do is that we just change everything back to x. So we add pi over 3. Right? And then we divide everything by half. Right? Then you can see that all these values lie between the given domain. So that's it for this transformed trigonometric equation, okay? So please bear in mind that unless you're asked to sketch the transformed graph, when you have to solve the equation, and when you see a transformed trigonometric graph, don't try to sketch the graph itself, okay, directly. You can make it like this and then always just use a normal sine, cosine, or tangent curve to find the answer. Okay. Because transformation takes a lot of time. So that's it for trigonometric equations. We're going to come back to this a bit when we learn more identities, but that's it for now, right? And what we're going to do is that we're going to look for some rules for solving geometric questions. So all those like sine rules, cosine rule, and area of a triangle. But I'm pretty sure for you've already done this in MYP and IGCSE. So I will not try many questions. I'll just tell you what it is and then how to use that, and then we'll straightly move on to more identities, okay? So sine rule. So if you recall the definition of trigonometric ratio, it only works for the right angle triangle, right? Then what about we have a triangle that is like acute triangle or obtuse triangle? So something like this. Then what we are trying to do is that we can use sine rule to find the information of a triangle. So in order to use sine rule, as you can see, there must be a pair of the angle and the length opposite to it. So you must know one pair to solve it, okay? So that's sine rule, and then the example should be fine. I'll include some difficult questions involving 3D diagram in the sample test, sample test. So you guys can try those questions. So cosine rule is also very simple. So these two, if you choose this as a pair, then we have this, okay? Then if you want to find C, and if you know this angle, then all you can do is that you can just let this as C squared. C squared equals to A squared plus B squared minus 2AB cosine C. Okay, so just decide which pair you want to use. Okay, and lastly, area of a triangle. So how do you find the area of a triangle? We know it by multiplying the height and the base and dividing it by 2, right? But what if we don't know the height? So let's say this is what you know. Okay, then the area of this triangle can be written as half AB sine theta. Then is this different from the previous formula that we know for area of a triangle? No, it's exactly they're exactly the same thing, and I'll derive this for you. So always remember that when you have to find the area of a triangle, the definition of area of a triangle is base times height divided by 2. And we can apply that here as well. So we first need the height, right? That means, why don't you just make a height like this? And you can see that this height can be written as a sine theta, because so height is the opposite, right, of this right angle triangle, and a is the hypotenuse. That means sine theta equals to h over a. So rearranging that, we have h equals to a sine theta. Then that means area must equal to the base times height by over 2, right? So we have half, we have the base, and we have the height, a sine theta, okay? So it's just the other way of writing half times base times height, okay? And please note that this angle must be between the two lengths, you know, okay? So for example, if you know this angle instead, and if you have AB, you cannot use this directly. You should either try to use sine rule to find this length and then find the area, or you can possibly use cosine rule, but seems like sine rule is easier. So yeah, that's what you can do, okay? So this is height, that's the base, and that's half. So it's just the same formula that we already know. Alright, so that's it. And yeah, well, one thing is that these are very simple, right? Unless you have to determine like how many triangles you can sketch, you can make, like with certain conditions. So for those examples, I will put it in the sample test. So please try those papers. Alright, so what we are going to do next is that we're going to look for the further trigonometric identities for SL students. So it's called the double angle identity. And after this, SL, you should be done with trigonometry. For HO, you have to know further, so a bit more, so compound angle identity and reciprocals of cosine, and a bit more inverse properties as well, inverse trigonometry ratios. So yeah, but we're going to start with double. So we're going to start with the basic first. And yeah, SO you have to know, HO you have to know the double angle identity as well, so please keep watching this video. So sine 2x, we can write it as 2 sine x cosine x, and the derivation is not that difficult because, so consider an isosceles triangle like this. Then let's try to find the area of this triangle. So first we can make a height, so then that means this angle must be x, right? So this height here, we can write it again using like what we did here. So this time that's the angle, so this height becomes the adjacent, and a is the hypotenuse, right? That means h over a is cosine x, so h can be written as a cosine x. Then what about this? This is the opposite, and the opposite can be, so let's say it's y, then we see that opposite can be written as a sine x, because opposite over hypotenuse is sine, right? So rearranging that, we have these two. So if you want to find the area, then area of this triangle is again half times base times the height. So what's the base? So that's y, then the base must be 2y, so it's 2a sine x. And what's the height? The height is a cosine x, so that means this 2 and half cancel, so we have a squared times sine x cosine x. And we can also apply this as well directly. So we have the angle between these two adjacent lengths. So that means area can also be written as half a squared sine 2x. And these two area must be the same, right? Because we have found the area of a same triangle. So we can equate these two. So a squared it cannot be 0, right? The length cannot be 0. So we can cancel out a squared, and then we can move this 2 half to the other side. So this is what we have for double angle identity of sine, okay? That's the derivation. And doing the similar thing you can do for cosine, but so the proofs are not that important. So I mean, if you want to know, then it's always very good to know. But what I mean by it's not important is you will not be asked in IB. So yeah, actually, yeah, I shouldn't have said it's not important. So everything is important. So it's important to know how you get all these formulas. So, but if you care about the efficiency, so if you just want to focus on your syllabus, then you don't have to know the proof. So cosine 2x can be written as cosine squared minus sine squared, and using the identity that we know, this identity, we can write this in terms of cosine only or sine only. So sine squared is 1 minus cosine squared. So we will have 2 cosine squared minus 1. And cosine squared is 1 minus sine squared. So it's 1 minus 2 sine squared. Okay. So you will see a lot of questions involving cosine 2x, and often you may not know which one to use. So I'll give you some so almost every types of examples, and then I'll tell you when to use what. Okay. So that should be in the sample test. So please try the sample test. Now last, the double angle identity for tangent. So this is what we have for tangent. Okay. So these are the 3 double angle identities that you have to learn. And please notice that not all, but especially this double angle identity for cosine, you'll see a lot in calculus again. And for HO students, yeah, probably you will see all these in complex numbers too, and also like vectors, but for vectors, SL students as well. So yeah, please remember these 3 identities. It should be in your formula booklet, but it's good to memorize it too. Alright, so for the first example, now let's try a trigonometric equation involving double angle. So we see that it's double angle, right? So we want to find x between negative pi to pi. So like what we did before, we want to make into a common subject, but we have cosine 2x and we have cosine x, right? So we cannot substitute it directly into to make a quadratic equation. So what we can do is that we can either try to change this into sine or cosine, and we've learned it here, right? So since we have cosine, then why don't we just change this into cosine only? So cosine 2x is 2 cosine squared minus 1. So that means 2 cosine squared x minus 1 minus 5 cosine x plus 3 equals to 0. So this is what we will have. And so if you can directly factorize it, it's perfectly fine. But if you can't, then or if it's hard for you, then we can use substitution to make it into a quadratic formula. Then you don't even have to factorize, because you can just directly use quadratic formula as well. But this question, I made it so that it can be factorized. So it's better to factorize as it's much faster. So we have two candidates, a equals to half and a equals to 2. So cosine x equals to half, or cosine x equals to 2. But does this make sense? And the answer is no, because the range of cosine must lie between -1 and 1, right? Cosine x cannot go beyond 2. Well, it can in complex number. So for HO students, you will see how we can find x for cosine x equals to 2. But if you're in SL or if you're in IGCSE, you don't have to worry about it. So we just look for this case, okay? So this one is rejected. So now, as I said, for finding values, it's the best to sketch and then find. So you don't have to sketch it nicely. You can just quickly sketch it. So we see that we have two values for this, right? Two intersections. So cosine equals to half. That means it's 60 degrees, but we have to use radians. So let's write it as pi over 3. Then using symmetry, it should be negative pi over 3. So x equals to plus minus pi over 3, and that's it. Second example. So let's try to focus more on double angle identity. So the main application of double angle identity is to find some more special angles. So what I mean by more special angles are something like tangent 15 degree, sine 15 degree, and cosine 15 degree. Alright, so you can start with anything you want, but for me, I will start with tangent 15 degree. So how do we find tangent 15 degree? We don't know anything about this, so why don't we just consider tangent 30 degree? So tangent 30 degree, so 30 degree is double the, right? So if you double 15 degree, we will have 30 degree. That means we can write this as 2 tangent 15 degree over 1 minus tangent 15 degree squared. So what I mean by squared is the entire thing squared, right? And we know tangent 30 degree, right? What is it? It's just 1 over root 3. And this tangent, we have to find tangent 15, right? But it's in quadratic, so why don't we just substitute this into a? Then we have 1 over root 3 equals to 2a over 1 minus a squared. So we can rewrite this as 1 minus a squared equals to 2 root 3a. So a squared plus 2 root 3a minus 1 equals to 0. So we want to solve for a, and unfortunately for this one, it doesn't seem like that factorization works. So we can use the quadratic formula, and I'll use the modified quadratic formula for even coefficient of x. So this is what we will have, okay? So 2 minus root 3 or minus root 3 minus 2. Okay, this modified quadratic formula, you don't really have to know this. It's just boosting your calculation. So what it means, what it is for, is that we know that this is the quadratic formula we know, right? But if b is an even number, we can see that we can cancel out this 2, because if b is an even number, then we must have 4 here, and we can take out by this 4, so we can cancel it out by 2, and then we can speed up the calculation. So if b is an even number, then we can use b prime as half of b, so it's negative b prime plus minus b prime squared minus ac over a. So if you don't like learning too many things, then you don't have to know this. But certainly for many cases, it boosts up the calculations. Anyway, so these are the two roots. But so that means tangent 15 degree can be 2 minus root 3 or minus root 3 over minus 2, right? And clearly this one is rejected because tangent 15 degree, where should it be? It should be the positive value, right? If you recall the sketch of tangent 15, right? So that means this must be the answer. So then we have found this, and we have to do the same thing for sine and cosine. Well, you can do that, but I'll use the definition of trigonometric ratio, because tangent 15 degree, that means this is 15 degree. That's, we can let this one as 1 and let this be 2 minus root 3, right? That's how we can find tangent 15 degree. Then what about the hypotenuse? Hypotenuse should equal to the sum of the squares of these two and then take square root. So this hypotenuse will be 1 plus 4, 3, 7 minus 4 root 3, is it? Yeah, and then plus 1, so 8 minus 4 root 3. So square root, so that should be 2 root 2 minus root 3. Yeah. So this is what we will have. So that means sine 15 degree should be 2 minus root 3 over 2 root 2 minus root 3. And then cosine 15 degree should be 1 over 2 root 2 minus root 3. Well, you can try to rationalize it twice, but I will not bother to do that. If you want to write this a bit nicer, you can just write it like that. And yeah, the same for this, but yeah, I'll rationalize this. So this is how we can find these three angles, okay? Special angles. And you can also find for something like let's see, 75 degree as well, because 75 degree is just a half of 150 degree, and 150 degree is symmetrical to 30 degree, right? So you can always use this. One thing to be aware of using this trigonometric definition is that sometimes you'll have the negative value. So for example, if you're looking for something like the obtuse angle, we know that using the ASTC, the old school teach crap thing from the previous video, we see that from when the angle is between 90 to 180, only sine is positive, so tangent and cosine must be negative. Then in that case, so once you find the ratio, you can just put negative sign for the things that you need, okay? So that's it for IBSL trigonometry. So yeah, that's it. And for HO, see you guys in the next video. So we have a lot more things to do. So